Alright, how you guys doing today out there in Math Magic Land? This is Mr. Muscarella coming at you, and in today's video lesson, we're going to take a look at solving logarithmic equations. This is going to be the first type where we're not really going to have to do too much. We're just going to set equal, solve, and then check. And so let's go ahead and review a little something first. The graph of f of x equals log of x. Now the graph, don't forget, is going to cross right here at the point 1, 0. Now the pieces that I really want to focus on, or the one piece that I want to focus on, is going to be the domain. Now notice the domain for this particular function is going to start, let's make sure you spell domain right. The domain for this is going to go from 0. It starts at 0 and then goes all the way on forever. So 0 and then forever. So we denote that by infinity. So it's got to be greater than 0. So any x that we pick, the values for x have to be bigger than 0. The range we're not really going to focus on right now, but we can see the range goes down forever, and then it continues and goes up forever. So the range would be all real numbers, or from negative infinity to infinity. But we're just concentrating on the domain, because that is going to play a part in solving equations that are logarithmic in nature. So let's take a look at an example. Now, when you take a look at this type of problem, the first thing you want to do is analyze the bases. All right, so log, now there's no number written right here after the word log, so you can assume then that base is going to be 10. So this is log of base 10, and on the other side, we also have the same thing, log of base 10. Now, since they both have the same bases, we're going to essentially get rid of the word log. So doing that, we're just going to set these two pieces equal. 3 minus 2x equals negative 3x minus 4. Oh my gosh. So we're going to do a little algebra. First thing we're going to do, because I like the variables on the left side, so we're going to add 3x to both sides. And that's going to be 3 plus x equals negative 4. And of course, when I solve that for x, I get x having a value of plain old negative 7. So I've solved this problem. I've set them equal, I've solved it, but now what I want to do is just kind of check real quickly. If I take this negative 7 and I plug it in to each one of these pieces right here, is that number, is what's on the inside, going to be something positive? So on the left side I'll have 3 minus 2 times negative 7, so 2 times negative 7 is or negative 2 times 7, so I'm going to have 3 plus 14. That's 17, which is positive, so that side is good. But I want to double check and go to the other side. So negative 3 times negative 7, and then minus 4. So that's going to be 21 minus 4, which is 17, which is also positive, and they are the same thing. So x equals negative 7 is the correct solution. So just double check to be sure, plug it back in. Some teachers are going to require you to write this out, and others are going to just require you to do it mentally, but make sure that you do check the number that you get is not an extraneous solution, but a solution to the equation that you just solved. So, take a look at another one. Here we go. Notice, both bases are the same, so just go into set them equal mode. You can probably do this one on your own. This is so easy. So, after you go ahead and copy down the problem, pause it, and then come back and check it out and see how you did. So how did you guys do? Did you get a value of x equals 1/4? And again, doing the check. If I do 2 times 1/4 plus 5, that gives me something that's definitely going to be positive. And if I put 1/4 in on the other side, I'll get something positive as well. Because negative 2 times 1/4 is just a negative a half. Plus 6, that gives me something positive. So x equals 1/4 is the correct solution. Now let's go ahead and take a look at one more example here. Check it out. What? Oh my gosh. So now, this time, we're kicking it up a notch because look, we're going to have a base. But this time it's going to be 14. So since it's the same thing on both sides, same base on both sides, here's the problem same way you did before. Set them equal, solve it, check it. So go ahead and do that and see what value for x you come up with, and if that value is indeed a solution, or if it's an extraneous solution. So go ahead, copy the problem, hit pause, let's see how you did. So how'd you guys do with this one? All right? Easy peasy, right? All right, I think you guys probably have it down by now, so we're just going to throw one more example at you. This one here, example number 4. So go ahead, notice the bases are the same, so you're going to use that same process. Set them equal, solve, and check it. Go ahead and hit pause, do the problem, and then come on back and see how you did. So how'd you guys do with this one? Did you get a value of x equals -5? That's pretty good. Hopefully your arithmetic is good on that, and you got the -5. But let's go ahead and talk about this. When we go to do that check and we plug in -5, and I'm just going to work on this left-hand side right here. I'm just going to think about plugging it in there. So when I plug in -5 to that piece, I end up with a value of log base 4 of -2. So since the value that I'm taking the log base 4 of is a negative number, that piece on the inside right there is negative, sorry, there is no solution to that. Now sometimes textbooks will just write it like that, or you'll do like an empty set with a line through it. But even though we got a value for x, this particular problem does not have a solution. That's one, always got to double check. Even though you get an answer, that answer might be extraneous, which means that answer does not count. And in this case, we get -5 for x, and there's no solution. So thank you for playing. That's it for this video. So hopefully by now you can solve these simple types of logarithmic equations. All right, you guys have a great day, and I'll catch you later. Peace.